Namaskar. Dear teachers, you must definitely have used maps as a learning tool in classroom setup, transacting about spatial information and distribution of physical and cultural features existing on the face of earth. Using maps as a teaching tool in geography is an effective way to enhance students' understanding of the world and its complexities. Maps provide a visual representation of geographic information, allowing students to grasp spatial relationship patterns and distributions. It is important to know about maps and its most important element, the grid of latitudes and longitudes, and understand its significance before we start using it in classroom teaching. Before we embark on this journey of understanding, let us get acquainted with the learning objectives of this session. The first one is to trace the history of map making right from the prehistoric era. Evolution of cartography as a modern science with the use of advanced technological tools. Discussing in detail about the latitudes and longitudes, one of the 5 basic elements of map making. Relationship of longitudes and time zones of the world. Application of this skill in everyday life and linkages across the subject to deepen the understanding of the concept. We are going to trace the history of map making known as cartography and its evolution right from prehistoric time to modern era. The earliest known maps date back to prehistoric times with simple drawings on cave walls and rock surfaces. These maps primarily depicted local landscapes, river systems, and other natural features. As civilization began to form, more structured and practical maps emerged, such as Babylonian clay tablets, Egyptian papyrus maps, and ancient Chinese maps on silk cloth. From 6th century BC to 5th century AD, which was a classical period of history, during this period, ancient Greek scholars made significant contributions to cartography. The mathematician and philosopher Thales of Miletus is often regarded as one of the first map makers. Later, the scholar Eratosthenes produced maps that included irregularly spaced grid lines of latitudes and longitudes. Hipparchus, a Greek astronomer, first used latitudes and longitudes as coordinates to identify positions. Ptolemy, the Roman geographer, greatly advanced cartography, with Ptolemy's Geographia being one of the most influential work. From 5th to 15th century AD, during the medieval period, map making became more focused on religious and symbolic representations. The famous Mappa Mundi in the Hereford Mappa Mundi from the 13th century is a prime example, depicting a Christian worldview with Jerusalem at the center. Islamic cartographers also made significant contribution during this time with maps like Al-Idrisi's Tabula Regeria. Then came the age of exploration. From 15th to 17th century AD, which was known as the age of exploration, it brought about a revolution in cartography. With the voyages of explorers like Christopher Columbus, Vasco da Gama, and Ferdinand Magellan, maps became more accurate and detailed, incorporating a newfound knowledge of the distant land. The advent of printing also allowed for the map production and dissemination of maps. The golden age of cartography began from 16th to 18th century. During this era, cartography reached new heights. Prominent cartographers like Gerardus Mercator and Abraham Ortelius made significant strides in map-making techniques. Mercator's projection, in particular, became essential for navigation and is still widely used today. The modern cartography, starting from 19th century, was related to the advancement in surveying, geodesy, and photography, and it greatly improved the accuracy and precision of maps. Governments and organizations began creating topographical thematic maps for various purposes, including military, scientific, and administrative maps. The rise of GIS or Geographic Information System technology in the latter half of the 20th century revolutionized mapmaking, enabling the creation and analysis of complex spatial data. Digital age and online mapping of the late 20th century till present time, the digital age and the map making revolution brought about a transformation in map making. Computer based mapping software allowed for the creation of interactive and dynamic maps. The advent of the internet and the rise of online mapping services such as Google Maps made maps accessible to a global audience and changed how people navigate and interact with geographic information. In summary, the history of map making showcases the evolution of human knowledge, technology, and exploration. From simple drawings on cave walls to sophisticated digital maps, cartography remains as indispensable tool for understanding and navigating our world. In the second segment, we are going to discuss about the latitudes and longitudes. The grid of horizontal and vertical lines, which are called parallels of latitudes and the meridians of longitudes, one of the 5 basic elements of map. This grid helps transfer the features of a 3-dimensional Earth on a 2-dimensional surface, that is, map. While booking a taxi through any cab booking application, you must have wondered how the taxi driver is able to locate your position as well as your destination. Actually, Google Map uses these latitudes and longitudes as coordinates to accomplish the task. The latitudes and longitudes are imaginary lines commonly referred to as geographical coordinates, as they provide systematic network of lines upon which the position of various surface features of the Earth can be represented. With the help of coordinates, location, distance and direction of various points can easily be determined. Latitudes and longitudes are measured in degrees because they represent angular distances. Each degree is further divided into 60 minutes and each minute into 60 seconds. Parallels of latitudes. The parallels of latitudes refer to the angular distance in degrees, minutes and second of a point north or south of the equator. These are imaginary lines joining places measured along the meridian of that place as an angle from the center of the Earth. The length of these lines keep decreasing as we go from equator towards the pole. The value of equator is 0 degree and the longitudes of poles are 90 degree north and 90 degree south. The total number of parallels thus drawn, including the equator, will be 179. Depending upon the location of a feature or a place north or south of the equator, the letter N or S is written along with the value of the latitude. For example, if we write the latitudinal position or parallels of Delhi, it will be 28 degrees 40 minutes 0 seconds north, because Delhi lies to the north of equator. Meridians of longitudes. The meridians of longitudes refer to the angular distance in degrees, minutes and seconds of a point east or west of the prime meridian or the Greenwich line. The meridian of longitude passing through the Greenwich Observatory near London has been adopted as the prime meridian by an international agreement and has been given the value of 0. The meridians of longitudes are semicircles that converge at poles as being shown on this diagram. The meridian intersect the equator at right angles, and unlike the parallels of latitudes, they are all equal in length. The longitudes vary from 0 to 180 degree east and 180 degree west, thus 360 total. If opposite meridians are taken together, as we see in this diagram, they complete a circle. but they are valued separately as two meridians as shown in this diagram. One is 0 degree and the other is 180 degrees. To take an example, the longitudinal position of Delhi is 77 degrees 10 minute 0 seconds east. Its value is suffixed by the word east because the part of the earth east of the prime meridian is called the eastern hemisphere and in its west referred to as the western hemisphere. And since Delhi is located in eastern hemisphere, its longitudinal position is suffixed with the word east. Longitudes and time, a very interesting aspect. We all know that the earth rotates from west to east over its axis. It makes the sun rise in east and set in the west. The rotation of earth over its axis takes 24 hours to complete one circle, that is 360 degrees of longitudes. As 180 degree of longitudes fall on both east and west side of the prime meridian, the sun thus takes 12 hours time to traverse the eastern and the western hemispheres each. Thus, the sun traverses 150 degrees of longitude per hour or 1 degree of longitude in every 4 minutes of time. It may further be noted that hours of the day advance when we move from west to east and decrease with our westward movement. Thus, we lose time when we travel from west to east and gain time when we travel from east to west. The rate of the time at which the sun traverses over certain degree of longitude is used to determine the local time of an area with respect to the time at the prime meridian, that is 0 degree longitude. Let us try to understand the question of the determination of time with respect to the prime meridian with the following set of examples. If we determine the local time of Mirzapur located at 82 degrees 30 degrees east longitude approximately when the time at Greenwich is 12 noon, the time increases at a rate of 4 minutes per degree of longitude east of the prime meridian. Thus, the difference between the Greenwich line and Mirzapur is 82 degrees 30 minutes of longitudes and the total time difference between Mirzapur and the prime meridian would be 330 minutes, that is 5 hours and 30 minutes. Thus, Mirzapur in India is 5.5 hours ahead of the time at the prime meridian at London. Now, a question arises. If the time changes 4 minutes with the movement of sun at each meridian, we have to keep adjusting our watch every time we travel outward, eastward or westward from our existing location. In order to maintain uniformity of time as far as possible within the territorial limits of a country, the time at the central meridian of the country is taken as the standard meridian and its local time is taken as the standard time for the whole country. The standard meridian is selected in a manner that it is divisible by 150 degrees or 7 degree 30 minutes so that the difference between its standard time and the Greenwich time may be expressed as multiples of an hour or half an hour. The Indian Standard Time is calculated from 82 degrees 30 minutes east meridian passing through Mirzapur as the example given earlier. Therefore, IST is plus 5 hours 30 minutes from GMT, that is Greenwich Mean Time. Similarly, all countries of the world choose the standard meridians within their territory to determine the time within their administrative boundaries. Thus, the world has been divided into 24 time zones of 15 degrees each. The countries with large east-west span may choose more than one standard meridian to get more than one time zone, such as Russia, Canada and United States of America. Now we come to the concept of international dateline. While the world is divided into 24 time zones, there has to be a place where there is difference of 24 hours. Somewhere the day truly starts on the planet. The 180 degree line of longitude is approximately where the international dateline passes. The time at this longitude is exactly 12 hours from the 0 degree longitude, that is the prime meridian, irrespective of one travels westward or eastward from the prime meridian. We know that time increases east of the prime meridian and decreases to its west. Hence, for a person moving east of the prime meridian, the time would be 12 hours less than the time at 0 degree longitude. For another person moving westward, the time would be 12 hours more than the prime meridian. For example, a person moving eastward on Tuesday will count the day as Wednesday once the international dateline is crossed. Similarly, another person starting his journey on the same day but moving westward will count the day as Monday after crossing the line. To avoid any confusion, 180-degree or the international dateline is not drawn straight and thus avoids the division of a country into different time zones. A famous 19th century French author, Jules Verne, made mention of this phenomenon, that is, the international dateline, in his travel adventure novel titled Around the World in 80 Days, which he wrote in 1873. Mr. Phileas Fogg, an English gentleman, takes a trip around the world accompanied by his valet to win a bet that he will make the journey in 80 days or less after he read in a newspaper that a new railroad in India has made it possible to travel around the world in 80 days. The wager is for a huge sum of 20,000 pounds, half of his fortune. Fogg and Passepartout board a train bound for Dover and Calais to begin their journey. During their journey, they come across many hurdles and difficulties which cause delays, but ultimately they learn that the journey through the time zone has gained them a day and that they have won the bet. Now, this is a map showing the route followed by Mr. Fogg to travel around the world. So, dear teachers, we can use maps for engaging students actively in their learning process by allowing students to explore different layers of information and perform data analysis, making the learning experience more dynamic and enjoyable. Teach them how to interpret and analyze spatial data on maps, discuss patterns, distributions, and spatial relationships, which will help them understand geographical processes and phenomena better, and to provide a comprehensive and engaging learning experience for students. Namaskar.